spoke about all of this stuff, right? So you're going to want to go to my last video to see all that. But in this video, I'm going to show you how to do certain different types of problems relating to hyperbolas. So here I want to write the equation for a hyperbola graph below. So this is a horizontal hyperbola, meaning horizontal, meaning my leading variable is x. So I know that my equation, my standard form, which for all hyperbolas look like this equals 1, right? And I know a squared goes first and b squared goes second. So my leading exponent is x, so it's going to be x minus h squared, and then y minus k squared. H was always with x and k is always with y, where hk is my center. So the question is, what is my center? My center is going to be this my buddy right here. Okay? The center is always going to be in between the two vertices. Kind of like a parabola has a vertex, it is going to be right in the middle of them. So my center is 0, 1. So that means that automatically I know it's going to be x squared, and then I have minus squared. I'm just going to fill in all the blanks, right? And I have y. So those are never ever going to be anything else except for x, y, and 1. Except unless it's a vertical, it'll be y, x, and 1. But x and y will always be in your equation. So I know that x, it's going to be x minus 0 and x minus 1. I mean y minus 1. Then I'm going to be consistent with my color coding from my last video. So my A value is always going to be from my center to my vertex. So it's going to be 1, 2, 3, 4, 5 units. So A equals 5. So that means that here is going to be A squared. So I'll rewrite it. I'll put 5 squared. And then I know that B is going to be from here up until the edge of the box. Remember that box is 1, 2, 3, 4. So B is equal to 4. So I have 4 squared here. And then if I rewrite it out, I have x minus 0 is just x. So I'm just going to rewrite that as x squared over 5 squared is 25 minus y minus 1 squared over 4 squared is 16 equals 1, and we are finito. Alright, next problem. I don't want this to be too long of a video, so if you need to pause it to relook at all this, you can, but for time's sake, I'm just going to go to the next problem. So, identify the vertices, the foci, and the direction of opening. Whenever it says identify the vertices, you're going to want to identify the vertices and the co-vertices. They're all considered vertices. They're just one's vertices and one's co-vertices. Now, I'm going to write all of the things that I need to find over here. So I need to find, I always put the center because the center is important for all of this. So the center, the vertices, the co-vertices, I'm going to write. Co-vertices, the foci, and I'll put orientation. Some of these we can answer just from looking at the equation. So automatically I know my center is going to be the opposite of this, which is -2 and -8. So it's -2, -8. And I know for orientation, because x is in front, it is going to be a horizontal orientation. So it's going to look something like that. Now, co-vertices, the vertices, co-vertices, and foci. So vertices are directly affected with A, directly affected with B for the co-vertices, and C for the foci. Okay? Now the question is, So what I always do on my paper is I do A equals and I write what it is. And again, A is always first. So what is the square root of 169? It is 13. So I'm going to rewrite it over here. A equals, no, I'll write it here. A equals 13. And I always make a little note to myself, what variable is that directly affecting? It is directly affecting x, so I rewrite it here, just x. This is just for my notes, so that when I do this with the vertices later, it's a lot easier. Now next, b is equal to the square root of, I'm going to rewrite this so we have all of our information in the same place. So we have a equals 13. Now b is equal to the square root of 4, which is 2. So b equals 2, and I didn't write it here, but this was x, and so therefore b is y. But we can also see that right there. C, we don't know, but we know that a squared plus b squared is equal to b squared is equal to c squared, as mentioned in the last video. So this is the Pythagorean theorem. So that means that 169, the cool thing is that our squareds are already given to us. So 169 plus 4 is equal to c squared, and 169 plus 4 is 173. So c is equal to, so this is c squared, so if I take the square root of that, so c, I can erase this, so c is equal to the square root of 173, which is equal to about 13.2. So c is equal to 13.2. And again, c is always the same thing as a because they're both on the transverse axis. So it's going to be x also. So with that being said, we got to look at our vertices. So our vertices, if my vertex is a units away in the x direction, then that means I have two vertices. That my y is always going to be negative 8. Negative 8 is not changing. But what that does mean is that negative 2 is going to be going up 13 units and down 13 units. So negative 2 plus 13 is equal to 11. And negative 2 minus, let's go minus, negative 2 minus 13 is equal to negative 15. And so that is how I get my points. And so again, with my co-vertices, that negative 2 is not changing. But what is changing is this negative 8. So negative 8 is going to go plus or minus that 2. So I have plus 2 is going to be negative 6. And then minus 2 is going to be negative 10. And then I put that comma in between. And so my foci are going to go in the same direction as, let's make that a little thinner, are going to go in the same direction as my vertices, so that negative 8 is still staying. And then I'm going to put the commas in early. And so 13.2. So it's going to be 13.2 up. So that's going to be 11.2. And it's going to be 13.2 down, which is going to be negative 15.2. And we already have the orientation. So just for, I don't know if I can do that, but just for color sake, because it's a little messy, so I have my center is negative 2, negative 8. My vertices are 11, negative 8, and negative 15, negative 8. My co-vertices are negative 2, negative 6, and negative 2, negative 10. My foci are 11.2, negative 8, negative 15.2, negative 8. and my orientation is horizontal. All right, next problem. And again, I'm touching on a bunch of different types of problems so you're able to complete them. So write the standard form of each hyperbola. Here you need to know how to complete the square. So if you don't know how to complete the square, you're going to have to watch a video on completing the square. So our standard form is always going to have a positive and then a negative, right? Because it's something minus something equals 1. So what I need to do is I need to group my variables, right? That's always the first step, just like with ellipses. But the way I'm going to group them is I'm going to take my positive variable first. So I'm going to group my y first, and you'll see why in a second. So I have y squared, and I'm going to put minus 14y, right? So let me color code this a little bit. So I have y, and then I have minus 14y. So I have y squared minus 14y, and then I'm going to take my negative, and I'm going to group them on the side a little bit more over. So minus x squared minus 18x. And I know the constant's going to end up going on the other side, so I'm going to put that immediately on the other side. So equals 132. Positive because I'm going to add it over. So let me put that here. Plus 132, plus 132, and that goes there. So now what I need to do is I'm going to first, before I start completing the square, I'm going to rewrite this. Y squared minus 14y. And I need to factor this minus out because I need minus something, right? So I'm actually going to take this minus completely out. And so I get minus, and this is its own group. And I have minus x squared plus 18x. I factored it out completely. Equals 132. That is really important. This step right here, you have to factor that negative out. So now I'm going to complete the square. So the way I complete the square, I do negative 14 over 2 equals negative 7, and I square that, which equals 49. So plus 49. But whatever I do to one side, I must do to the other. So I have plus 49 here. And then here, I have 18 divided by 2 is 9, squared is 81. So I have plus 81, but here's where a lot of people are going to mess up. Here it is a plus 81, but that is technically a minus 81 because of the distributive property. So it's minus 81 here. So what do I end up getting in the end? Here I get y minus 7 squared minus x plus 9 squared equals this whole thing, which is 132 plus 49 minus 81, which is, I did all this work, which is 100. So I get 100. And then I just go from there and I finish doing it just like I did with ellipses. So remember, this has to equal 1. So what I'm going to do is I'm going to divide out this 100. I don't want to use too many colors, so I'm actually going to put that all in black. So minus 100, not minus, divide by 100, divide by 100, and so I get, if this was a plus, it would be a circle. That's important to know, but because it's a minus, it's hyperbola all of a sudden, like immediately. So my final answer is going to be y minus 7 squared over 100 minus x plus 9 squared over 100 equals 1. There's your final answer. So my question is, okay, is this a vertical or a horizontal hyperbola? It is going to immediately be vertical because of that y. So this is going to look something like this and this, where this is 10 units away. This is also 10 units away because A is 10 and B is 10, right? And you know this just from looking at this. And the center is, of course, -9 and then 7 is my center. I'll write that down here, actually. So I know my center is -9, 7. I know it is a vertical hyperbola. And A is equal to 10, B is equal to 10. I know that immediately just from looking at this. Okay, so now graphing. Graph the hyperbola. This is where it gets a little bit difficult, but I think these are the hardest problems, but graphing can be also a little bit difficult. This is an annoying problem because we don't have perfect squares here, but we'll estimate. So what is my center? That is the first thing you're going to want to do, is identify what is the center. And your center, so let me write this here. Center is, again, comes from your x and your y here. Now, is this going to be horizontal or vertical? I know immediately it's going to be horizontal. So horizontal. Okay? My center is going to be 0, -1, because this is technically x plus 0, and there's a -1 here. So I'm going to automatically plot my center. Okay, so it's going to look something like that in the end. What is A? So A is equal to the square root of 20, which is equal to, for about, approximately, I'll put approximately, so 20, which is approximately 4.5. And this is in, again, the x direction. I'm going to put it a little bit off to the side. X. B is equal to the square root of 10, which is approximately 3.2, and that is in the y direction. And then lastly, C is equal to the square root of these two added together, right? Because a squared, I'll write it here, a squared plus b squared equals c squared. So it's 20 plus 10 equals c squared. So c squared is equal to 30. So c is equal to the square root of 30, which is approximately 5.5, and that's always in the same direction as A, so it's x. So x, y, x. I'm going to erase this just for all the room. Now, we need to map this out. So in the x direction, we're going 4.5. So 1, 2, 3, 4.5. 1, 2, 3, 4.5. And in the y direction, we are going 3.2. So we have 1, 2, 3.2-ish. 1, 2, 3.2-ish. Okay? And then we draw that box that we spoke about. So it's like going to be weird because it's not lattice points, but it's okay. Close enough. Okay, so there is my box. So immediately from drawing my box, I can draw my asymptotes. So what I do is I draw them. I'm going to make these a little thicker because it's important to be able to see them. And I'm going to put them in some like yellow so that they're there. Too light. Let's try this. Let's go green. So from here to here. So it's really important to be able to see them because these are used to help us graph. Okay, so those are our asymptotes. They go from the corner to the center. Okay, so let me redraw the center so it's visible. So my hyperbola is going to start at my vertex, right? And it's going to go, I know it's horizontal, so I'm going to go from my vertex to approach my asymptote and approach my asymptote. And so here I have my vertex, and I'm going to go horizontal. And there, I drew my hyperbola. But I also need to draw my focus, which is going to be here, which is 5.5 units away. So this was 4.5, so I just go one more unit in, and one more unit in, and there are my foci. So that is literally everything you need to graph it. So you need your box, so it makes your asymptotes. But what we need to find is what are the equations of the asymptotes. That's the last thing we need to do. So to find the asymptotes, remember, it's rise over run. Our rise is our B and our run is our A. So it's going to be y equals plus or minus. So it's B over A, x minus h plus k. Okay, looking exactly like vertex form of a parabola. Okay, so we have plus or minus B over A. B is square. We're just going to estimate here. So we have 3.2 over 5.5. If these were whole numbers, I would keep them as whole numbers, but because they're not, we have to just estimate. So we have 3.2 over 4.5 x minus h, which is 0, plus k. So this happens to be an easy type of problem because the x value is 0, so this becomes plus or minus, this is about 0.7, so 0.7x plus k, which then just becomes y equals 0.7x. Oh, we didn't put in k. This is minus 1. Minus 1, and y equals 0.7x, negative 0.7x minus 1. So there are two asymptotes. Which, again, you have to look at it. Does it make sense? Yeah, they both go through minus 1. One is a positive slope, one is a negative slope. Sometimes you'll get something that makes no sense, right? So here's how you would do it. So let's say if I was going through 1, 8, and A was equal to 4 and B was equal to 2, and it was a vertical. This is a whole different problem. And it was a vertical hyperbola. Okay? Vertical hyperbola is the opposite of this, meaning it's going to be y equals A over B plus or minus x minus h plus k. So here I have y equals plus or minus 4 over 2 x minus 1 plus 8. So I use all three of these pieces of information. And so I get plus or minus 2x minus 1 plus 8. This is where you split, kind of like the quadratic formula. I have a plus or minus, so I need to split it. And I have y equals 2x minus 1 plus 8, and y equals negative 2x minus 1 plus 8. And then I distribute this, and I get y equals 2x minus 2 plus 8, which is 2x plus 6. And I get negative 2x plus 2 plus 8, which is negative 2x plus 10. So those would be my two asymptotes.